waiting for our next speaker is going to be online, remotely presenting.
Oh, I can hear and see you. That's great. I assume, can you hear and see me?
Yes.
Right. Shall we start?
Yes, please.
Right. Good morning, everyone. So my presentation is going to be on visualization libraries and which one should I choose. So it's going to be a quick whistle-stop tour, but an interesting and an important subject, I believe. So this all started from, this is about a year old now, a general 5-minute kind of internet news article. But all of a sudden you start looking at this and you're going, well, you know, there's 30, 40, 50 different libraries you can choose from. And there are new libraries coming out literally every week. You know, on my news feeds, there's a new open source library coming out. And the actual landscape is getting very cluttered, very confusing. And so the question is, which one do you choose? So to start answering that question, I would recommend actually just stepping away from the libraries themselves. The first thing you need to really do is understand exactly what you want to do. What is the goal for your visualization? And the two images at the top for me are pretty much the starting point. The one on the left is talking about form and function. What functionality are you trying to achieve with your visualization? Is it just a general presentation? Is it a visualization for an article that's got to follow APA 6th edition standard? Or are you going to the other extreme of trying to do some visual analytics application that's got lots of interaction? An EDA type of application where it's more kind of exploratory. And then the one on the right is, again, something worth thinking about. Lots of visualizations nowadays are basically works of art. You look at them, they are stunning, they are crafted, and they're not really, I would say, visualizations that have come from a standard package. And I'm not saying there's anything wrong with them. They do their job within their context, within their domain beautifully, but they are a work of art, and they are more created by a designer, an artist, rather than an extreme of someone who's just throwing data into kind of Tableau, or someone such as myself who's a programmer, software engineer, who's happy using particular libraries in a computer program. So with respect to your starting point, what is your basic requirements? What is your goal? And from there, using these two kind of images as starting points, just lay out those goals and those requirements. And that's probably your first starting point with looking at the skills that you need. I cannot do a data art. I'm just not creative enough. So that does begin my initial consideration of what I can and can't do. So what I'm going to do now is quickly fly through 3 or 4 different libraries out there and talk about the differences and things you might not be completely aware of. The first one is Matlablib. It's a Python library, and it's a really good standard library that has tens, if not hundreds, of different types of visualizations. Now, that does introduce and bode the question of what type of visualization do you need for your data, but that's a whole different presentation workshop in itself. The point here is, though, with a pretty standard library that lots of other libraries are built upon, you can pretty much find exactly the type of visualization you want if you want to do some more or less kind of static type visualization. Now, the next one, again, it's a Python library called Bokeh. It's much more geared, or you can do static visualizations with it, but if you want to follow and try and do something like an exploratory data analysis app, or maybe a visual analytics, then Bokeh is introducing the idea of having all your widgets within your visualization, your interactions, having sliders to do kind of filters, buttons to select things, turn things on and off, text boxes to allow you to kind of enter data to filter this, to filter on, say, a number. And it is, again, a reasonably accessible library. It is in Python. But what people don't necessarily realize is that behind the scenes, it's actually encompassing a client-server architecture. Now, what's good about the library, as I said, is that it encapsulates that and takes that away from the user. So you don't have to be a full-on web stack developer, but you've still got that functionality available to you. So behind the scenes, back end, it uses a Tornado server. It's built primarily on Python, although you can integrate some JavaScript. But the visualizations themselves are built with HTML, CSS, and Bokeh's version of JavaScript, or flavor of JavaScript, I should say, basically built on top of a HTML5 canvas. So as I said, you don't have to understand all of that technology. You just have to be a reasonably good Python programmer. But what it also now introduces is the idea of having an element of design skills, being able to have an efficient and an effective layout that's usable by a user. Yeah, you can just throw things onto the screen, but to make this visualization now usable, you have to have that design skill kind of within your little box. Excuse me. Now, moving on from that, I mean, I said behind the scenes it uses kind of JavaScript, but it's taken away from you. There are obviously a lot of JavaScript libraries out there, and probably the most well-known one is D3. And the same as Matlablib, which is a base for a lot of other Python-esque libraries, D3 is very similar. There are lots of other JavaScript libraries built on top of D3. But if you really want to go down to the original one, then D3 is is your choice. Again, out the box, it has a whole series of visualization templates, presentations, and you will pretty much find what you need from those. Now, the difference between D3 and say Bokeh is you are now actually developing in JavaScript. You are developing the HTML, the CSS. So where Bokeh encapsulated that away from you, you're now in the weeds with this within using kind of D3. Do you have that skill? So, I mean, I'm getting to the point now where I believe I'm pushing the kind of boundaries of what I can do with Bokeh. What's required from the users, the functionality is not in there as the kind of within its framework. So I'm now having to think about, okay, I know I can do this if I move to a web stack development kind of framework. But that is a whole set of different skills. It's separating it out. So you need someone to understand how to set up the server, how to do the back end. You need the person to do the front end development. You're going to do a single page application and understand all of those essentially kind of like web frameworks. It is beautiful what you can do with it, but it's a different kind of skill set. Now, the next one I'm going to mention is Vega, which is based on a visualization grammar. Now, this has evolved from the idea of a grammar of graphics. So if you want to look at R, there's ggplot2, and even Matplotlib to a certain extent is built on a grammar of graphics. And this is the idea of basically building your visualization up in layers. They're much more static orientated, so you have your kind of axes, you have your labels, you have your ticks along the axes, you have your titles, but it's a very systematic way of building up your visualization. Now, Vega takes this to the next step, and it's called a grammar of interactive graphics. And it's the idea of moving away from the static images and introducing again those interactive elements, your sliders, your buttons, and so forth, but in a completely non-programmatic environment. So the grammar is basically a JSON format file, and there's an example on the right. It has a syntax. You have to get the syntax right, otherwise it won't kind of load. But you don't have to be a programmer, and you can build reasonably sophisticated interactive applications with it. So it's a lot more accessible for those people who don't want to touch programming in any kind of like fashion. And what's nice about it, and always happens, is there are tools coming out to even extract away from you the element of having to type in this grammar within a kind of a text editor. Now, our Shiny is, again, Shiny itself is a really nice package. It's art orientated, very much like Bokeh in that it introduces all the sliders and the grammars, all the sliders and the interactive elements. It takes away the HTML and the CSS and the JavaScript for you. And it's great to build an interactive visualization on your desktop. Now, what people forget or get a bit left-fielded by is that they want to then move it from their desktop and make it public, make it accessible to the to the general kind of audience. And this is where you then have to actually have something called a Shiny server. So again, it's web orientated, but to publish anything on the web, you need some kind of back end, and that's what people often forget. You can get the Shiny server, there's the RStudio Connect, but it has to be set up, it has to be supported, it has to be maintained, and then your Shiny application has to be deployed into it. And again, it's one of those elements that people often forget, and it's one thing we often get here. I've got my application, runs really nice on my desktop, I want to now publish it. Well, you have to be aware of all this back-end support and maintenance, which is already doable, but again, it's something you have to consider when you're developing your project and what your eventual final goal is, because you probably won't be able to maintain that server yourself. You'll have to go to another service within your university to implement it and support that for you. Now, moving from predominantly what you could class as 2D into now 3D, we have visualizations or frameworks and packages based on WebGL or WebGL2. And probably the most famous one for me is basically the open source frameworks from Uber. And they are great. And they are great, though, for particular domain and context. So we've now moved from 2D into 3D. There's no point using 3D, there's no point using these libraries unless you really need to use the functionality they offer. But again, they're JavaScript based. You have to understand how JavaScript works and build this from scratch. But what you can do with it is very sophisticated. And predominantly the examples you get from Uber are much more on the kind of geo-visualization domain. If that's not your domain, don't even bother looking at the kind of libraries. Now, the final point I'll make is going back to the kind of the technical element and the kind of the beauty element, the truth and the beauty, which was the image on one of the first slides. Any visualization will take a lot of work. It takes planning. You know, there's lots of drawing, prototyping, and this final slide is an example of that. So visualization network using some kind of graph framework. The image on the left, a wonderful piece of art, excellent visualization, very informative, and it's like, great, yeah, I'm doing some networking stuff. I'm using a graph library. That's what I want to do. The image on the right, unfortunately, was my very first attempt. I got all my data into my graph framework. I pressed the visualization button, and that's what it looked like. And frankly, it's a bit of a disappointment. So the statement I was probably trying to make is any visualization will take a lot of work. You'll see all the examples. They look amazing. You need to put some time and effort in to actually get them to that state. My next 3 or 4 versions of my graph network did look a lot better, but they're still a long way off from looking like the image on the left-hand side. Just bear that in mind when you're planning, or maybe you collaborate and work with a designer or an artist if you're more programming based, to get those ideas of what works out on paper first and use that again as part of the requirements, use that to influence maybe the type of library you want to use. And after 14 minutes and 30 seconds, I shall stop there and leave a couple of minutes for any questions. Thank you very much.
All right, thank you, Simon. Any questions? Do you have examples of your, it looks like kind of a bug splat there, the one on the right, of how it improved?
Not to hand, actually. But yes, it probably does look like a bit of a bug.
All right. Oh, here we go. Good.
Thanks for the nice overview. We've used Bokeh and Matlablib and a variety of other things. And basically, my graduate students pick whatever they feel is useful, but then they have to learn JavaScript or Python, or they know some of it already. Do you have suggestions on how to recommend what new students should play with if they don't take the initiative to do make their own choices?
Could you just repeat that again? You broke up a little bit.
We use Matlablib and Bokeh and a variety of other things that you mentioned. And currently, because there are so many different options, this means typically that most graduate students pick something and then learn how to actually do something with it. And depending on their programming and artistic skills, this may turn out really well or not so well. I think this is fine, and they learn JavaScript or CSS or Python or a variety of other things that are useful for other purposes as well. But do you have any recommendations if a new student would work on something, what to pick or what to how to decide what to put effort in?
Okay, right. It is a very grey area. So one example from personal experience, going back to, so part of my work, part of my research is using mixed reality, and I'm playing with magic leaps. So what I want to do is bring some of these visualization libraries into an immersive environment. As a side note, if you're using the kind of 2D ones, if you've got like a large immersive display, then it's not too difficult to, basically just scale your desktop app into a much larger immersive display. But with the Uber open source ones and the Magic Leap, I'm having to weigh up and juggle a lot of different kind of work. So I've made the actual choice of, with the Magic Leap development, to go down in the path of using MagicScript, which is their flavor of JavaScript, which I can then hopefully, and this is what I'm looking at the moment, introduce those WebGL JavaScript-based libraries into that hardware Magic Leap environment. So part of that answer is basically, you can't learn everything. Looking ahead, what is going to be most useful to you? A lot of my work is in Python, so I have a bias towards using those libraries, and that's one reason I chose Bokeh for some work I've done, rather than going down and using R, Shiny, and that platform. So it's looking ahead really and saying, what do you want to do? And from a student's point of view, you could say, what career path do they want to take? If they want to be a web developer, then I would say, okay, you'll get a lot more out of focusing on using the JavaScript flavored libraries. If you're going to be a data scientist, then you can then probably choose Python or R, whichever is your kind of language of poison. If you're not really going to even be a software engineer, then there's nothing wrong with using something like Tableau. You don't have to actually program or develop anything. So look ahead of how you can be most efficient with your time, and you've got to develop things. Does that answer it okay?
Yeah, that's actually similar to what we've been doing or suggesting. These are graduate students in biochemistry or chemistry, and data scientist is an obvious future direction to the stuff that we do.
Yep.
Not as much, but some people just like playing with web development tools, and they
Yep. The one thing I would say though is data is agnostic as such to whatever library and language you're using. So there's no reason why you can't, from a data science point of view, actually use maybe Python backend to do pre-processing and to wrangle your data and get it into a form that's ready to be visualized, and then actually use R to do the visualization. Or even develop it into a JavaScript app. The final point I'll make is where I think I've pushed the boundary of Bokeh for what I want to do. I'm now looking to do a full web stack development environment, and I will probably have Python backend using a Python server, but I will use JavaScript front end and design a single page application and use like a REST API to communicate between the two. Now, I'm not expecting everyone to understand all those terms. It's more the point that I'm using an array of different languages. So don't feel you have to stick with one, within your pipeline, within your workflow. There's no reason why you can't mix and match. At the end of the day, it's your workflow of what is most efficient and most effective.
Apart from visualization, for data science careers, Python is unavoidable these days. That might change 5 to 10 years from now, but at the moment you need Python. Just for the data wrangling part, that's the visualization part.
I have a little wry smile on my face because there's a couple of groups here who would argue differently. They are very much R-based. They have no interest in doing Python. I'm with you on this.
Talking corporates, data science jobs. Anyway, this is getting a bit off topic, I suppose.
Good, yeah, thank you. So, Kurt, remind me, what about something like Paraview, which is kind of mostly GUI based, but it does have some Python backend programming abilities, and now you can one-click VR if you want to go in, a simple VR interface.
Yeah, you could say my talk's been more based around data visualization, information visualization, and not really scientific visualization, which I would push Paraview into that arena. But one element, I was thinking about this last night of how I could take, or how anyone could take some of these visualizations and put them more into like a cave setting or VR. And this is where something like Conduit from obviously from Matlablib could be a perfect example. Matlablib itself doesn't have the hooks into a virtual reality environment. It is predominantly, not predominantly, it is a desktop environment. But that's where using middleware, something like Conduit, and especially even with the Uber kind of WebGL frameworks, could definitely be an avenue of getting that more into virtual reality and mixed reality environment.
The problem with Paraview is that it has a very high steep learning curve in practice. We used it, and some people got quite good at it. Compared to many other tools, it takes a lot of effort to get results out of it, in our experience.
Right.
Yep.
Okay, got any other questions? All right. Thanks again, Simon. So,
thank you very much.
Yeah.